Hi everyone, welcome to the series on microservices in .NET 6. So this series contains total 5 videos. This is the first video. It's about the introduction of the microservice architecture. Okay. So before going to understand the microservices, we just go through the existing most common architecture, that is monolithic architecture. Okay, monolithic is a traditional or most commonly used for developing the application. Okay, in this approach, all the business units or logics are implemented under a single application. So monolithic means single. Under single application only, we are going to build all our business logic inside of our application. Okay, and it's most probably communicate with a single database for serving the data in the application. Okay, so monolithic architecture just look like this. So let's think like we have two endpoints like product API and orders API. So if you follow monolithic architecture, what we are going to do? We are going to create them in the single web API application, right? So like this, if you have n number of endpoints, all the n number of endpoints will be under the single application and they're going to consume single database, right? So this is how monolithic architecture works. Now let's understand microservice architecture. So in microservice architecture, each business unit or logic is developed as a separate small individual application. Okay, here we are separating into small apps. That is nothing but microservices. Okay, so each separate application is lightweight. Okay, since we are separating, and they have their own responsibility to carry on, and these individual services are called microservices. Okay, splitting of a big logic into small logic as small applications is a microservice architecture. Okay, so in microservice, each service has its own code and its own database, right? So in monolithic, we can see single database inside of the single application every endpoint consumes, right? But in the microservice, every individual application or microservice has its own database. Okay, so any service down. Okay, so each are divided into individual applications, right? So each will be hosted individually. So if one microservice is down, it won't affect another services because they are not dependent on each other, right? So whereas in monolithic, every logic is under single application, right? So if one is down, entire application might be down. Okay. So each microservice can be hosted anywhere in the web app. So they are very small, lightweight applications, right? So they can be hosted on anywhere in the web, and each microservice can be interacted with own individual database. So each has its own database and their own respective table. Okay, and this database can be either can be SQL or MongoDB. Okay, for suppose if I have two microservices, one microservice can consume SQL database and another microservice can consume MongoDB, something like that. Okay, so this is the microservice architecture, and you can see here we are separated at the small applications. Like one application contains product API endpoint, and another microservice application contains orders API. And here you can see it has its own DB, like products API consumes DB like manufacture database, and order API consumes like sales business database. Okay. So there might be a chance we need some information between the two microservices. So in that case, we can use RabbitMq message broker for asynchronous communication between the two microservices. Okay. So in this demo, I am using RabbitMq message broker. There are a lot of other message brokers like Azure Bus. Anything you can want, you can use it for asynchronous communication between the microservices. And here you can see API Gateway. So API Gateway is nothing but another small application where we are going to have a single domain. Okay. You observe here microservices are individually hosted, right? So their endpoints or domains will be different. So if we have n number of microservices we want to consume in our UI application, then we have to define n number of domains and their URLs. But whereas if you use microservices, sorry, API gateway, we can map all our microservices endpoints into the API gateway, and our UI applications, our client applications, simply invokes the gateway API gateway application. So API gateway will communicate internally with the respective microservice and deliver the response to the client. Okay, so we are going to accomplish a small microservice application in this series based on this diagram only. Okay, so our second video is on creating the products API microservice. Okay, and third video will be the creating the order API microservice. Okay, and fourth video will be the synchronous communication between the microservice 1 and microservice 2. Okay, and final video will be the implementing the API gateway. So that is the flow of our this microservice.NET 6 series. Okay, so that's about the introduction of microservices. So I'm going to close this video by creating databases for my microservice application. So here you can see there is a database, manufacturer database, and sales business database. Okay, each database is consumed by respective microservice, right? So I am going to show some scripts to create the tables and the database for the respective microservices. Okay, so create database for microservices. So let's create two SQL databases like manufacturer or sales business. If you want to use MongoDB, you can use that as well. Any database if you want. I am using just SQL database. Okay. Each database will be used by the microservices. Okay. So each database will be used by the respective microservices. So this is the script for in the manufacturer database. I want to create the products table. Okay. This is the products table. It will have columns like ID, which is a primary key, name, cost, description, and created date. So this is the script for my product table. And here you can see here sales business database and table name is orders. So this is the script for orders table inside of the sales business database. Okay. So it contains ID, user ID, product ID, and order date. Okay. These are my sample database and the tables. Hi everyone. Welcome to the .NET 6 microservice series. So this is the second video. Okay, in this video we are going to create a microservice application, which is nothing but a web API application. In that we are going to implement the products endpoint. Okay, so this is our microservice architecture flow. So here you can see red highlighted box that represents today we are going to implement the products microservice. Okay, so here we are going to do some basic CRUD operations. In that CRUD operations, I will implement only create and read operations. Okay, to make our video short. In general, we will implement all the four operations like create, read, update, delete. Okay. So let's jump into create a microservice application, which is nothing but a web API application. Okay. Okay, here I am using .NET CLI command for creating the API project, and here I am naming my API project name as Manufacture.API. Okay, so let's create the project. Okay, project has been successfully created. Now let's open the project in the Visual Studio Code editor. Okay, here is our API project and target framework is .NET 6.0. Okay, now let's install NuGet packages like NT Framework Core and SQL NuGet packages. So first let's install Microsoft.NT Framework Core NuGet package. Since I am using CLI, I am going to copy command from here. Install it. Now let's install Microsoft.NT Framework Core.SQL Server. So this package for communicating with the SQL database. Install it. And we know that we are creating the microservice that contains product endpoint and it consumes the manufacturer database, right? From this diagram. So let's go to my SQL Management Studio. Here you can see the manufacturer database and the product table. Okay. So this table will be consumed by our product endpoint. Okay. So in this we are going to use the code first with existing database. First, let's create the class. Okay, that represents our table products. Okay, let's create a folder like data. Instead of data, create a folder like entities. Okay, inside of it, let me add my class, table class, that is products.cs. Okay, this is our product class. So let's add the properties that are equivalent to the table column names. Okay, finally our class look like this. Now we need to create the database context class. So database context class is nothing but a class that has control over our database. Okay, manufacturer database. Okay, so for that, let's create a class inside of the data folder. Okay, I will name it like manufacturer context.cs. Okay, this is our manufacturer context class. Currently, it is a plain class. Make it database context class. It should inherit DB context. Okay, that loads from Microsoft Entity Framework Core. And now let's implement the constructor. Context options, just specify our class name, its type. Okay, pass the options to the base class. Okay, now inside of this context class, we need to register our table class as a DB set. Okay, so public. Okay, this is our context class. Now go to app settings.development.json. Here, let's add the connection string property. Okay, inside of it, let me add my manufacturer database connection string. Okay, so let's add a property like okay. Here, let's add database connection string. Okay, after adding the database connection string, let's register our manufacturer context into the program.cs file. So to register our DB context into the program.cs file, services.add DB context and specify the type of our context class. Okay. Use SQL Server and here we need to pass the connection string. So to pass the connection string, builder dot configuration dot get connection string and pass the property name of the connection string. Now let's create our products controller. Let's add products controller. Okay, here is our controller class. First, let's inject the our database context here. Okay. Okay. So we have already initially discussed that we are going to create two operations, that is create and read operation. So first let's uh, implement create operations so that we can add some data into the database. Okay, so let's add my action method. Okay, here is our PostyAsync action method. Okay, so it should be a HTTP post request. Okay, so if we have single post method, then we don't need to specify the explicitly route value. Okay, and now here what I can do, context dot products dot add our new product and await manufacture, sorry, context dot save changes async. Okay, so it will save the newly added record into the database. Okay, now if you want, you can give directly the newly created record as a response. Okay, but it is recommended is it is always good to return a get URL. Okay, get endpoint that fetches the newly created record by its ID. Okay, for that we need to create a get action method. Okay, okay, and it is a HTTP get, and it will be the secondary get method because I am going to implement the another get method to fetch the collection of data. So that's why we need to specify some route value here. In that route value also, I'm going to specify just the ID dynamic value. Okay. So if you open brackets, that means it is a dynamic route value. So this value will be read as the input parameter of the method. Okay. Now product equal to products dot find async. Directly I can pass the primary key ID value. Okay. And I will return okay as a response and the product. Okay. Now we have get endpoint by ID, right? So what we will do, we will return created at action, and here we have to pass the action name, that is a get action method, right? So I can simply say get, and it have query properties, right? So those values I have to pass here. So new product dot ID, and finally I want to return response, my newly created object. So what this create action method will do, it will generate a get action by ID, this action endpoint URL, and it will add it to the response header. Okay, and in the response we will see the newly created object. So any UI can grab that URL for get the details of the newly created record. Okay, and here is small correction. I haven't assigned context. Okay, now let's run and test our endpoints. Okay, create endpoint. So here you can see we have two endpoints. One is for products get by ID, another one is creating the product. So let's go to products post and try to add a record. Okay. Okay. Let's try to post the data. And here you can see 201 status created. And you can see the newly created record. Its primary key has some value. Okay. And here you can see in the header, response headers, in the location value, you can see the endpoint was generated by the action method. So this value can be read by UI application so that can get the details of the newly created recorded. So if I execute, I need to get the data. Okay. So that's all about the create operation. Okay. Now let's implement one more action method to fetch all the records from the database. Okay. So it is a overloaded getAsync method, but it will fetch us all the data. Okay. Now here I need to decorate with HTTP GET. I won't give any route. Okay. By default, GET method will be recognized by the endpoint, and I want to get all the products, right? Okay, that's it. This is our endpoint. Let's test it. And here you can see one more get method. Okay, products. So let's try to execute. And here you can see we got the response. Okay, so we are done with the create and read operation. So here if you observe this entire web API application, it's only take care of the products. Okay, products endpoint, and it will only deal with the products table in the manufacturer database only. Okay, so that means it is very simplified code, means only single module of code we are using. So this is called microservice. Okay, microservice is nothing but any application with minimum are a separate module of the logic. Okay, here I am dealing with only products with this application. I won't implement any other logic into this application. If I implement, I am going to violate the rule of microservice. Okay, so this is the microservice. Okay, so we have successfully completed our products API endpoint microservice. So in the next video, in the same way, we are going to create the one more microservice application. In that, we are going to deal with the orders API, and that orders API will communicate with the its own database, that is sales business database. Okay, so that is the upcoming video. Hi everyone, welcome to the .NET 6 microservice series. Okay, this is the part 3 video of this series. So in this video, we are going to create a microservice application for orders endpoint. Okay, in the second previous video, we have created a microservice application for products endpoint. So this is the second microservice. In this microservice, we are going to create the orders endpoint. Okay, so here we can see the flow of our demo of our .NET microservices. Okay, so here you can see highlighted box. So I am going to create the orders API in another microservice application, and this orders API has its own database, something like sales business database. Okay, so let's jump into creating the .NET 6 web API application, which will be our microservice application. So here is the .NET CLI command for creating the API project, and I am naming my project name as SalesBusiness.API. Okay, let's create the project. Okay, project has been successfully created. Let me open my project in Visual Studio Code Editor. Okay, here is our web API project, and target framework is .NET 6.0. Let's first install required NuGet package like EF-Core and EF-Core SQL packages. Now, the package we need to install is Microsoft.NT Framework Core package. So copy the package, install it. And the next package we need to install is Microsoft.NT Framework Core.SQL Server. Okay, copy the package, install it. And we know that our microservice that contains order API going to consume sales database, right? So let's go to SQL Management Studio. So here you can see sales database that contains orders table. Okay. Now let's create a class for this orders table into our application so that I can interact with the SQL Server table using the NT framework code. Now let's create a folder like data. Inside of it, let's create another folder like entities. And now let's add our table class, that is orders.cs. So into this orders class, let's add the properties that are equivalent to the names of the table columns. Okay, so our order class look like this, and here we need to observe one thing, that is product ID. Product ID is nothing but, if you recall our previous video, we have created the product endpoint, right? So that API consumes products table. So the same ID we are going to save with the orders table. Okay, and here we can observe there is no product information like product name like that, right? So how to get that product name into this microservice application, we are going to do it in the next video using the RabbitMq message broker. Okay, until then, just keep in mind we are just going to save the product ID into our orders endpoint. Okay, so now let's create the database context. Okay, so inside of the data folder, let's add a class like. Okay, okay, now it is just a plain .NET class. To make it database context class, we need to inherit DB context that loads from the NT framework core. Okay, now let's create the constructor and pass some database options. Okay, and type will be our context class itself. Okay, and now we have to register our table classes into our database context so that we can interact with our SQL tables. Okay, to register the table classes, we have to use the DB set. Inside of the DB set, we have to define the type as our table class name. Okay, okay, that is our DB context. Now let's add the connection string in the app setting.development.json file. Go to app settings.development.json file and let's create a connection string and give them property name like. Okay, here add your database connection string. So after adding connection string, let's register our database context into the program.cs file. So builder.services.add db context, and here we have to specify the type of our context class. Okay. And here we need to define our connection string. To do that, builder.configurations.get connection string. To this connection string, we have to pass our connection string property. Okay. Okay. Now let's create a endpoint for orders. So let's add the controller like orders controller. Go to controllers and create like orders controller. Okay, this is our order controller. Now let's inject our database context into the constructor of the controller. Okay. In general, microservice is itself a very small application where we are going to contain just basic CRUD operation like create, read, update, and delete operation. Okay. To make our demo short and sweet, I'm going to implement only two operations, that is create operation and the read operation. First, let me implement the create operation so that we can save some data into the database. Okay. So let's implement the create action method here. Okay, this is my post action method. Since it is only single post action method, no need to specify the route explicitly. Endpoint can recognize the post endpoint action method, and it should be decorated with the HTTP post method verb. Okay, and now we have the orders as the input for this action method. So what I will do, I'm going to call context orders.add a new orders, and we are going to call save changes async for saving the data. Okay. Now, if you want, you can directly return the newly created object with the OK method. But it is recommended way is along with the newly created record, we have to return some URL. So that URL should be identify the record newly created. Okay. So the UI can use that URL for getting the details of the particular item. So that means we need to create a get action method by ID. Okay. So first let's create a one get action method. So this is my get action method. It should be decorated with HTTP get, and I have to specify route explicitly because I need to pass the ID value. Not only that, I'm going to create one more get async method where that method returns all the data from the database. So for this method, I am going to explicitly specify the route. So here is the dynamic route value. I am giving ID. So whatever value will be in the route will be read by the action method. Okay. So now where order equal to find async, and I can pass ID directly. And we can simply return the item with OK method. Okay. So we are done with the action method. Now let's go to our create action method and let's return the response. So here we are going to use the create at action. Okay. So for this we need to pass the get method name. So it's going to generate a URL for us. Okay. Filter by ID. This action method URL will be generated by this created action. And here we have to specify the any routes we have. So we have dynamic value ID, right? So we have to specify as the second parameter, and third parameter will be the entire newly created record. So what it will do means it will return the newly created record as a response, and it will generate the get endpoint by filter ID as a in the response as a header, so that UI applications can use that URL for binding, so that users can view the details of the newly created item. Okay. I have to specify dot ID. Okay. I will insert record again. Okay. So let's add some random value as a user ID and the product ID. Copy it. Okay. And now try to create order. Okay. Now order is created and you can see the URL is generated. So if I copy this and open, I need to fetch the item details. See. Okay. So that's how create operation will work. And next we are going to write another get action method that's going to return all our orders as a response. So what I will do, I will create another get action method. Okay, this is my another get action method. It should be decorated with the HTTP get. Okay, and I want to return all my orders. So I can use to list async. Okay, and I simply return OK. Okay, that is our get endpoint for returning all our data. And here small correction, it should be awaited. Okay, now run on test our endpoint. Okay, here is our orders endpoint. Okay, let's execute it. And here you can see our data is came. But here you can observe our order is fine, but we don't know what is the product, like product name, something like that, right? So we don't have product information in our uh, sales business database order table. Okay, how to achieve that? Okay, so that will be explained in the next video. Okay, for that we are going to use the RabbitMq message broker for sharing the asynchronous data between the two microservices. Okay, so from this diagram you can see, right, we have completed the orders API, and previous video we have completed the products API, and I have mentioned, right, in the next video we are going to share the data between products endpoint and orders endpoint using the RabbitMq message broker. Okay, we are going to implement that in the next video. Hi everyone, welcome to .NET 6 Microservice series. So this is the fourth video. In this video, we are going to deal with asynchronous data communication between microservices using RabbitMq message broker with Mastransit. Okay, so the main theme is how to asynchronously we can communicate our both microservice application. Okay, with the help of message broker like RabbitMq. Okay, so if you recall our previous video, we have created a microservice application like SalesBusiness.API. In that we have an endpoint like orders, right? And we also observed that in the orders we only have product ID, but there is no uh, relevant information regarding the product in the orders. Okay, how we can achieve the product information while we invoking the orders API as well. Okay, so today we are going to accomplish that goal in this video. Okay, so here is our flow of our microservice architecture project. Okay, we have created microservice one that contains product API, and we have created another microservice application that contains order API. Now here you can see message broker that is going to create a asynchronous communication between these two microservices. So here my goal is whenever a product is created, okay, a product is inserted into the manufacturer database, means we are going to invoke the products post endpoint, right? So whenever we are going to save, at that time we want to send that product information as a message to the message RabbitMq message broker. Okay, so that what will happen, it that data or that message can be read by our another microservice application, that is sales business API application. Okay, and then once that message is received from the message broker, what we will do, we will create a one more product table in the sales business database. So this product table is a child table. Okay, so manufacturer database contains parent product table that contains all the columns like product name, product description, product actual cost, product offers, everything will be inside of that table. But here we are going to create a tailed product table. It will contain exact data of this manufacturer database, but it will contain only required properties. Like for this demo, I will create only table columns with product ID and product name. Product ID is the primary key that should be matched with the parent product table, and product name that will display the what is the product user is ordered. Okay, so we are going to create a table. So using this consumer configuration inside of this microservice application, we are going to insert that data into the child product table. That means here an asynchronous communication is going on. Okay, why? Because whenever the product is saved in the manufacturer database, at the same time, same data will be saved into the sales business database, into the child product table. Okay, that communication is carried over by the RabbitMq message broker. Okay, so what is RabbitMq? RabbitMq is a message broker. We know that it has several type of exchange flows. So let's understand them. So RabbitMq supports different exchange types like direct, topic, headers, and fanout. Okay, by default, RabbitMq uses fanout exchange. So same fanout exchange we are going to use in our demo as well. So we also use this fanout exchange for our demo. So in fanout exchange, whenever a producer sends a message, okay, whenever producer sends a message. So in our application, what is the producer? Producer is our products API endpoint. Okay, whenever producer sends a message, RabbitMq, then the message will be sent to the fan out exchange. So something like a disk memory that is allocated to the RabbitMq. There it will create like a fan out exchange. Okay. So message will be stored into the fan out exchange. So whenever the message is stored into the fan out, that message will be pumped or pushed over to all the queues, every queue that is connected to that our RabbitMq message broker. Okay, it will send every queue that message. So once the queues are registered with the consumers, so whenever the message is arrived into the queue, consumer will read the message. Okay, so in our project, our sales API, SalesBusiness.API project will be our consumer project. Okay. So here is the pictorial representation of the RabbitMq fan out. So whenever producer sends a message, that message first goes into the fan out. So whenever the message is in the fan out, every queue in the RabbitMq will receive that message from the fan out. Okay, fan out will send to every queue. So those queues will be consumed by respective consumers, so they can read the message. Okay, this is the RabbitMq fan out exchange flow. Okay, so I have also mentioned along with the RabbitMq, we are also going to use Mastransit, right? So what is Mastransit? So Mastransit is a free open source software that can wrap around message brokers like RabbitMq and Azure Service Bus or SKS or Active MQ Service Bus. So it is a software, okay, to handle the message brokers very easily. It can be very helpful for the configuration. So Mastransit makes the configuration very easy with the message brokers. Okay. So now what we will do, we have to run RabbitMq or set up RabbitMq into our local machine, right? So I am going to use the Docker image running as a container in my system. Okay, so it is very easy to configure the Docker, right? So I am going for Docker based containerization for the RabbitMq. So what we'll do, we are going to create a Docker compose file for RabbitMq so that we can easily run the container for our RabbitMq image. Okay, so here our projects are creating, right? So let me create a new folder like Docker setup. Okay, open VS Code. So in this folder, we are going to create the Docker compose file, right? So let's add our Docker compose file like docker-compose dot YAML file we have to create. Okay. So here we are going to add our setup. So first is version. So this version is for the Docker setup, Docker compose file. Okay. So latest version is it will support is 3.8. You cannot give a random. Docker compose by default support some versions. You have to give those versions only because based on that version, the syntax compatibility will work. Okay. So after creating version, we have to register our service, right? So we have to create a property like services. Okay. So inside of this service, we have to define name to our service. So I want to run RabbitMq, right? So I will create a meaningful name like RabbitMq. Okay. Under this, I want to define the original name of my RabbitMq. Okay. Docker name. So the original name is RabbitMq. Okay. Version 3 management. So if you want to check this, you can go to the Docker Hub where you can find the image name as it is and the versions, what are the latest version. Currently at the time of recording, it is 3 and the management. Okay. And next we have to define the ports. Okay. So ports. So first port is here I am going to define two different types of ports. So first port is whenever we run a RabbitMq provides us a dashboard. So first we have to define the port for the dashboard. So by default, the dashboard port runs under 15672. Okay. So I have to export this port. So what I will do, I will export this port to same port number. If you want to give different port number, that is also fine. Okay. And it should be okay. So this is the port for the dashboard, RabbitMq dashboard. So next port we have to define, that is actual port of the RabbitMq. So actual port of the RabbitMq is 5672. Okay. If you want to expose same port number, you can expose, but I will expose for different port number, custom port number. I will export for 4001. Okay. So first port number is the dashboard port number. Second port number is the actual RabbitMq software runs port number. Okay. And finally, let's define the container name for my image to run. Okay. You can give any name. So I will give name like my RabbitMq. Okay. So to run this in our local machine, this Docker composed file, we must install Docker desktop and it must be running before we run this Docker compose file. So let me run my Docker desktop application. You can download it from the Docker official website. So based on your operating system, it provides the desktop application. If it is a Mac, you will get the Mac version. If you is a Windows, you can download the Windows version of the Docker desktop application. Okay, let me open it. So here you can see my Docker desktop is up and running. You can observe like this Docker desktop application. Now let's run the our RabbitMq Docker image container. Okay, so the command is like docker -compose up -d, means detached mode, run this container. Okay, container is up and running. You can see container my RabbitMq started. Okay, and now you can access the RabbitMq dashboard with this port number. We are exposing with same port number, right? So here you can see, right? Docker, this is the Docker desktop, sorry, not Docker, RabbitMq dashboard website. So default password is like guest, username and password also guest. Okay, you can see dashboard like this. Okay, here you can see exchanges. Okay, our messages we can see here. Okay, so that means RabbitMq is successfully running in our local machine with the help of Docker image container. Okay. Next thing is we have to create a shared library. Okay. So in that library, we will create DTOs or models. So those DTOs are for messages, transferring the messages to the RabbitMq. Means those are the types for our messages of the RabbitMq. So we are going to create a shared folder and those classes, so that shared class library will be imported into the both our microservice application, so that we can use those types for publishing or consuming the messages from the RabbitMq. Okay, first let's create the class library. Okay, here is my command for creating a class library in .NET Core. So command is like .NET space new space class lib space -o space name of your class library. Okay, let's create the shared class library project. So in real application, you can convert this library as a NuGet so that we can easily import into our application in real time scenarios. Okay, so now let's open the project. Okay, this is our class library project. Let's delete the existing class file. So let me delete this existing class file. So our main target of this library is to store the models of our RabbitMq, right? So what I will do, let's create a folder like RabbitMq models. And in this demo, we want to deal with the message transfer between the two microservice applications, that is creating the product, right? So I will create a model like product created, okay? Product created. So I have already mentioned, right? I just simply want to transfer or save product ID and product name into the new child table that we are going to create in sales business, right? So message contains only simple data, that is product ID, which is primary key of the original product table, and next product name. So let's define those properties here. Okay, so our product created looks like this. Now just build the project. Okay, now our library is successfully built. What you have to do means we have to add the reference of this project into our both microservice application. So from Visual Studio, it is very easy. From .NET CLI comments, I will show how to add the references of the other class libraries. So here is my command for adding the shared library to our manufacturer API. So command is like .NET add and manufacturer API folder name and the CS project name is reference, and next shared project folder name and shared folder project. Okay, let's add the reference, and you can see that shared library is successfully added. Same way we have to add the our shared library into the SalesBusiness.API. So let me create the comment for that as well. Okay, so here is the comment for adding the shared library into the Sales Business API. Sorry, let me correct me the comment. Okay, now both the projects contains the shared library reference. Now first let's try to configure the publisher in the products endpoint. So to configure publisher configuration, let's go to our Manufacture.API application. So here we want to configure the publish, means that going to communicate with the RabbitMq to publish some message. Okay, so in this PostyAsync action method, we are going to implement the logic. Okay, so to use the RabbitMq along with the Mastransit, we need to install 3 NuGet packages, okay, that are relevant to the RabbitMq and Mastransit. So first let's install them. Okay, so these 3 NuGet packages need to be installed on both the microservice applications. Okay, both the applications. Okay, the first NuGet we have to install is Mastransit. Okay, so copy the command from .NET CLI. Visual Studio users can copy the command from package manager where so I am using .NET CLI, right? So I am going to copy from here command. So first I am going to install in the manufacture.api project. So run the command. So the second command I have to install is Mastransit.AspNetCore. Okay, copy the command, install it. The third package that I am going to install is Mastransit with RabbitMq. Okay, copy the command, install it. Now let's configure the RabbitMq and Mastransit services into the program.cs file in manufacture API. Okay, so go to program.cs file. So let's register services and add Mastransit. Okay, let's import the namespace. Okay, here let's add some options. Okay, here I want to first configure the RabbitMq as a message broker, right? So to configure RabbitMq, we can use use RabbitMq. Okay, so to this RabbitMq, we have to pass an anonymous function. Okay, context and config. And here I need to specify the host because I am explicitly specified the port number, right? So I need to define the host here. Okay. So to define the host, config dot host, that we can pass new URI. Okay. To frame the RabbitMq URL host, we have to specify like RabbitMq / localhost. And what is the port number? Actual RabbitMq service is running. RabbitMq service running under 4001. So same port number we have to define here. Okay. And next we have to pass the credentials for the host. Okay, default credentials like username and password are cached. Okay. So let me define username and value is guest, right? And same way password value is guest. Okay. So that is the services we have to register for the RabbitMq along with the Mastransit. So this is the use of Mastransit where we can configure RabbitMq very easily and simply. Okay, now we configure the required RabbitMq services. We have to publish our message. So to do that, go to ProductController. Okay, and we have one interface like private read only. I publish endpoint. Okay, publish endpoint. So let's import it from the Mastransit. Okay. So what it will do, it will act as a publisher for messages to the defined service. What we defined inside of the Mastransit, we defined the RabbitMq, right? So it will publish the message to the RabbitMq. So we can inject the I publish endpoint. Okay. So now in the post method, once the record is saved into the product table, okay, in the manufacturer database, we have to send the message. We can use I publish endpoint. Okay. And here you can say publish. And here we have to define our model that we defined in our shared library, that is product created. Okay. The type of the message. Okay. Product created. Okay. So let's import the namespace. Okay. And inside of it, let initialize the product created object and pass the data. So ID will be the, so what it will contain ID, which is the primary key of the product table. So new product dot ID, once record is added, ID will be populated. So we can consume that. Next, name of the product we want to pass. Okay. So new product dot name. Okay. So whenever we create a new product, once that is saved into the database, its information will be pushed into the RabbitMq fanout exchange using the publish endpoint. Okay, so that's the changes we have to add in manufacture API microservice application. Okay, next thing is, okay, now the thing is we need to create a product table, that is a child product table. We have to create in the sales business database. Okay, so here is the script. So this contains only two columns like ID and the name. Okay, after creating, you can observe in sales database we have a child product tables along with the orders table. So the product table contains ID and name, whereas the original product table that is in the manufacturer database that contains more number of product information. Okay, so like this our DB structure looks like this once we create the child products table. Okay, now in the sales business API we have to create a model for this products table, and also we have to add it to the database context. Okay, so go to the sales business project. Okay, here we need to create one more entity in the entities, that is like product.cs. So this is our products entity. Let's add the columns as a properties that are like ID and the name. Okay, so our products entity look like this. Now let's register this entity in the DB context as well. Okay, so here let's register our products entity as well. Okay, and now we have to install all the NuGet packages what we have installed previously into the Manufacture.API project here as well. So our sales business is act as a consumer. Okay, consumer project. Okay, but we need same NuGet packages. So the first package I want to install Mastransit. Copy the command. Install it. So the second command I have to install is Mastransit.AspNetCore. Copy the command. Install it. And the last package that I want to install is Mastransit.RabbitMq. Copy the command. Install it. Okay. Now we have to register the RabbitMq and Mastransit services into the program.cs file. But before registering them, we have to create a consumer entity inside of our sales business project. So in manufacture API, what we did, we just injected publisher, right? So publisher it will not always connect with the RabbitMq. Whenever message is available, at the time if it is connected, that is fine. Whereas consumers should not be like that, right? They always interact with the RabbitMq queues, so that they can, if any new message come, they can read them, right? So for that we have to uh, create a one consumer class inside of our sales business API. So for that, what I will do, let's create a folder like consumer. Inside of it, let's add a entity like, so we are dealing with product created message, right? I will name like product created consumer. Okay, so this is my consumer class that is always listens for the RabbitMQs to read the product created message. Okay, okay, this is my class. Currently, it is a normal plain class. To make it a consumer, we must inherit with iConsumer interface. Okay, of type. So let's import the namespace Mastransit. Okay, that iConsumer comes from Mastransit, and what type of message we want to read. We know that we have created a shared class library like product created class, right? So we need to import it here. Okay. Now let's import the implementations. So this method gets invoked every time whenever a new message is arrived into the RabbitMq queue from the fanout exchange. Okay. So here what I will do will be asynchronous call, and here I am going to inject the my database context. Okay. Okay, injected the sales business context. Now we have to receive the message from the RabbitMq queue, right? So from this context we can read. So what I will do, let's create our product. Okay, so new products, my table class name. Okay, let's change the name, correct it, products. Okay, and in the context also products. Okay, and now let's import the products namespace. Okay, now it is good. And what it will have id, so context dot message dot id. So message type is nothing but our product created type. Okay, and the name context dot message dot name. Okay, so we have received our message. Now what I want to do, I want to save it into the database. Okay, products dot add product and await save changes. Okay, so this is our consumer class. What we are doing, we are reading the message and saving into the database. Now go to the program.cs file and let's register our Mastransit and RabbitMq and also our consumer service. Okay, so to do that, builder.services.add Mastransit. Okay, let's import the namespace. Okay, and define the options. So first thing, let's add consumer to the Mastransit. Okay, consumer of type product created consumer. Just we defined a class, right? That class we have to register here. Okay, so copy that name and register here. Next, let's register the RabbitMq, use RabbitMq, and inside of it, similarly like previously we have defined, right? Same way we have to define. Okay, so what I will do, I will copy it from the our manufacturer registration. Okay, okay, I have registered the host, but here we need to register additional configuration like consumer with the queue name. Okay, so config dot receive endpoint, and here I can define the queue name. Okay, name of the queue, anything. I will name it like event listener. Okay, so from this queue, let's read the messages. Okay, like that. And here we need to configure the consumers. Okay, configure consumer. Okay, and here also we have to define the product created consumer type here. Okay, and here we need to pass the context. So that's it. So it's almost similar to the registration we initially did for manufacturer API, but only changes we need to configure the register the our consumer entity, and also we need to register the queue name of the RabbitMq and the consumer that is going to read that queue. Okay, that's all. We are done with the changes. So let's test our asynchronous data communication. So for that, what I will do, first thing, make sure our two projects running under different port numbers. Means my sales business API and manufacture API runs under different port numbers or not. Okay. So to change the port numbers, if you want, you can go to the properties and go to the launch settings. Okay. So my port number is like 5139 for sales business API, and for manufacture API, let's go and check, and 5137. So those two are different port numbers, so there is no problem for me. Okay, 7177 HTTPS, and for HTTPS 7135. Okay, so non HTTP 5139, and here 5137. So those are running on a different port number. That is the first step we have to check before running, and make sure our Docker desktop is running, and also our this is my container for the RabbitMq, right? That is also running. So here my both the applications are running. So now what I will do, I will run my manufacture API first. Okay. Okay, this is my manufacturer API. It is up and running. Same way, let's run the our sales business API project microservice as well. Okay, my sales business also running, and here you can see our manufacturer products table, which is a parent table. It is empty, and manufacturer, sorry, products table, that is a child table in the sales business database, that is also empty. Now, if our communication, asynchronous communication between our microservice is successful, whenever we create a product, it will be stored in main table that is inside of the manufacturer, and also child table that is inside of the sales business. So let's go to add one product. Okay, go to the product. So if we successful, then both tables get be populated with the information because of the asynchronous communication. Okay, let's try to add a new product like metric dumbbells. Okay, so some 1000 bucks and workout tool. Okay, so let me create this product. Okay, and here I got success, product is created. Now if I go to my first table, main table, let's check whether it is added. See, this Patrick Dumble record is added. Now let's check our child table. If our asynchronous data communication with the RabbitMq works, this table should get the data. If I run, see, with same record ID, I have product table. That means my asynchronous data communication with the help of RabbitMq message broker is successful, right? It is successful. Now what I can do, so here is my orders in the orders table in the sales business, right? So what I will do, I will update the product ID for the, I have only one record, right? So I will update it. This is my old record when we don't have asynchronous communication at the time created record. Okay, let me update product ID for it. So product ID like 8002. Okay. Sorry, 102. Okay, let's update it. Okay, so now I have an order for this product. Now, whenever I invoked orders endpoint, now I have to get the product information as well. So our sales business have now product information as well, right? Now we need to fetch the product information as well along with the orders. So for that, let's go to our manufacturer API, sorry, sales business API. Okay, let's close all the open files. So first, let's create a DTO for our orders. Till now, we haven't created any DTOs, right? So create a folder like DTOs. Inside of it, let's create a DTO class like orders DTO that contains product object as well. Okay. Okay, here is my orders DTO. So let's create the properties. Okay, finally my DTO orders DTO class look like this. It will have product information as a product object. Okay, now go to our orders controller. We need to update the get endpoint. Okay, so what we can do, we can use join. Okay, we want to join with orders with product table, right? So let's do that. We want to join by the product ID, right? And it should be product ID. Okay, and order comma product order product. Okay, we need to select them. Dot select new orders DTO. Okay, so here we need to map the properties. Okay, so here is the changed query. So what we are doing, since now we have product information, we are joining them. Okay, now save everything and run the endpoint. Okay, now let's test our orders get endpoint again. And now okay, you can see previously we have only product ID, right? We have product information as well. So we have successfully implemented the asynchronous data communication between the two microservices. So in this video, we have finally accomplished our RabbitMq message broker for asynchronous data communication between our two microservices. Okay. So next will be the last video of our series where I am going to create a API gateway to make a single domain for the client applications to consume different microservices endpoints. Okay. Hello everyone. Welcome to .NET6 Microservice series. And this is the last video of this series where we are going to integrate the API gateway for our microservice application. Okay. So this is the flow of our entire series, right? We have created microservice that contains product API. and another microservice that contain orders API, and then we have implemented RabbitMq message broker to communicate asynchronously between both the microservice applications. And finally, today we are going to implement API Gateway into our microservice flow. So what is the need of API Gateway? Okay, consider our microservices. Okay, till now we have created, right? Where we have two microservice applications. Okay, the Manufacture.API applications, let's assume it will runs under localhost port number 7132, and the Sales Business API runs under localhost port number 7456. Okay, so from this we can understand we have two different domains bound to each microservices, right? So different port means in real time there will be a different domain. So each microservice will have its own domain or URL. So in the real world application, we may deal with 10 plus microservices. Currently for our demo, we are only created two, right? But in the real time, there may be 10 plus microservices based on our businesses. In that case, handling or managing or consuming 10 plus different domains by a client application is very hard. So these microservices are nothing but the APIs. Ultimately, they need to be consumed by some client-side applications like Angular or React or Vue.js, any kind of JavaScript or mobile applications or any desktop applications need to consume, right? All those are comes under client category, and all of them it is very difficult to handle the different domains. So to solve this problem, API Gateway comes into the picture. Okay, so API Gateway is also a simple API project. Okay, it is nothing different. It is also API project with its own domain. But we will register our all microservice URLs with our API Gateway URL. Okay, with appropriate paths. So now we will expose only API Gateway URL to the client. Okay, so when client calls API Gateway endpoint, so client only requests the API Gateway endpoint. Okay, so behind the scenes, API Gateway invokes the appropriate microservice URL based on their registration. Okay, so on receiving the response from the appropriate microservice application, API return the same response to the clients. Okay, so API Gateway is a bridge between the microservices and the client application. Okay, and here is my manufacturer API, and it runs under 7117177. And here is our sales business microservice API, and its URL is 7135. Okay. Now let's create a one more API project that act as a API gateway. So here is my .NET CLI command for creating the web API project. So let's create the API project. So project has been successfully created. Let's open my project in Visual Studio Code Editor. Okay, so here is our API project, and to make it as a API gateway, we will install Ocelot API Gateway NuGet package. So Ocelot is an open source .NET framework where it is has the ability to work as a API gateway. Okay, so this is the NuGet package Ocelot we have to install. Since I am using .NET CLI command, right? So I am going to copy from here. If you are using Visual Studio, make sure to copy from the package manager. Okay, install the package. And I have mentioned, right, we have to map our microservice API with the gateway API, right? So make to map the URLs, we have to maintain a JSON file like Ocelot.json. Okay, let's create a file like Ocelot.json. Okay, two main properties of this Ocelot.json are routes, okay, and it is an array type. And one more thing, that is global configuration. Okay, so our main URL mapping all goes under this routes array. Okay, so to map a our microservice URL, we have to add a property like downstream path template. Okay. So this downstream path template should contain the our microservice endpoint which we want to map. Okay. So in our manufacture API, I want to map the products API, right? So for that, I want to copy the path. Okay, this is the path. Products is my path. Okay. And one more thing, it is the array, right? We should create an object inside of it and add. Okay. So that is about downstream path template where we define our microservice path. And next we have to specify the scheme of the microservice. So for that we need to specify a property like downstream scheme. So scheme is nothing but HTTP or HTTPS. We will use HTTPS. Okay. And next we need to specify the downstream host and ports. Okay. For that we need to specify downstream host and ports. Okay. It should be an array and inside of it we will have properties like a host. So what is our host? Our host is a local host. In real case, in real time example, it will be our domain. Okay. Is also an object we need to define. Okay. Because a microservice can have n number of bindings at the server, right? So we can have n number of domains for single microservice application as well. That is why the downstream host and ports are array object. Okay. And next we have to specify the port number. So what is my port number? 7177. Okay. So these are all the required configurations from the microservice that we want to map. So next we have to specify a property how it should be mapped to the API gateway path. So we have to define the API gateway path. Okay, here that will match this original microservice path. Okay, so it is the mapping path. So for that we have to specify property like upstream path template. Okay, so I will map the path like, so my project is manufacturer, right? So I will add a manufacturer and I will use remaining path. Okay, so this is the mapping URL, means this URL will be exposed to the client. Okay, whenever client invokes this path, okay, this is the API gateway project, right? So what it will do, it will compare or map the relevant original microservice path. So it will again invoke the original API call. Once the response is written, then the response will be delivered to the client. Okay, in that way API gateway works. Okay, and we can specify this template path should be work for what are the different HTTP methods. Okay, for that we can define a property like upstream path method, and this method is a array, and here I can specify get and right, because products, if you consider the products, you can see right here is my get and post method, right? So it should work for both get and post method, same URL. So here I am specifying it should be based on HTTP method request type. This URL must work for both, like get and post. Okay. Similarly, I can map my sales business endpoint as well. So for that, copy paste this one. Okay. And if I go to my sales business API, if I go to orders endpoint, so my endpoint is orders, right? So what I will do, this is my original microservice endpoint path, and scheme will be HTTPS, and host will be localhost, and port number will be different, right? 77135. So register that one. Okay. And this is my sales endpoint, right? Sales microservice. So I will add sales. Okay. So I have registered my product endpoint and order endpoint of my microservice. But this path I defined will only work for uh, this get all async and post all async. If you want to filter by ID, these paths won't work. Okay. For that, we have to define another set of configurations. Okay, similar to this. So for that, what I will do, will copy all configurations. Now I want to map endpoint filter by ID, right? So here I can specify. So braces represent dynamic value, any value is sent. Okay. So I will map like ID. Similarly here as well. ID, ID. So I have registered all my endpoints in both the microservices. Okay. So this is the this is how we have to map the endpoints in the API Gateway application. Okay. Next, we need to configure Ocelot microservices and its middleware. Okay. To do that, go to program.cs file, and here first I need to load the Ocelot JSON, right? So builder dot configuration dot add JSON. Okay. And pass the name of our JSON file. So it will load the JSON file when our application starts. Okay. Next, I need to register the Ocelot service. So here builder dot services dot add Ocelot. Okay. So let's import the namespace. Okay. What I will do, let me import the namespace manually using Ocelot dot dependency injection. Okay. So service also registered. Now I need to register the Ocelot middleware. So Ocelot. Now import the namespace of the middleware and wait it. And it should be waited. Okay. Okay. So what we did here, we loaded our Ocelot JSON and registered our Ocelot service and added Ocelot middleware. Okay. That's it. Now, if I run my application, for Ocelot API, you need to have Swagger. If you want, you can remove those middlewares. And now I want to access the, let me go to my Ocelot JSON file. So, and here small correction. I have written like host. It should be port. Okay. Port, port, port. Okay. Now rerun the application and test our endpoints. So let's first test the products endpoint. So what is the mapped path of my API gateway manufacturer slash products, right? So copy that path. Okay. Paste it over here. See, I am getting products, but the path, the domain is API Gateway domain. What is the original domain? Localhost 7177. But I am getting the products through API Gateway. Similarly, let's test orders as well. Okay. So what is the orders path? Original microservice endpoint is /orders, and our API gateway mapped is sales slash. Sorry, here also small correction. It should be orders, and here also corrected orders. Okay. Okay. Now copy the orders path. Okay. And okay. Now load it. See, now I got orders as well. But what is the domain? Domain is the API gateway domain. What is the original domain of the sales? 7135. Okay. Similarly, I can get products by ID as well, since I have registered that also, right? And I want 8002. See, I got this one. And if I want orders also by ID, I get that one too. 1002. Okay. So I got orders. See, now we will expose only this domain to the client application. We won't expose our original microservices domain. We will only expose our API gateway domain. So client applications can easily handle the URLs for invoking the API call. Okay. That is the importance of integrating API gateway into the microservices flow. Okay, so that is the end of this .NET 6 microservices. I hope this video has delivered some useful information to you all. So if you like my video, please support me by subscribing to my channel. Soon we are going to meet with new videos. Until then, signing off.